Dear students, today we will discuss on the derivation of phase rule. We know that the degree of freedom is equal to C minus P plus 2. This equation, we know that by using this equation we can find out the degree of freedom. In this lecture we will find out this equation. For this, firstly we discuss these two equations. Okay, we have these two equations and we have to find out the values of the x and y. Therefore, for in this one we maintain the 4x in this equation. Therefore, for maintaining 4s in this equation, you have to multiply this equation by 4. Therefore, this equation becomes 4x plus 8y plus is equal to 4 into 60. Okay, therefore, from equation number 3, you have to subtract the equation number 2. Okay, when you subtract 4x plus 5y is equal to 4, then your total equation will be, in this case, 8 minus 8 minus 5y is 3y and is equal to, you found that 16 minus 4, its value is the 12. Therefore, y is equal to 3, and by putting 3 in any one equation, you found the x is equal. Therefore, in first equation, x plus 2 into 3 is equal to 4. Therefore, x is equal to 4 minus 6 minus 2. Okay, this equation, if we have provided the two equations and there is a two variables, then both variables are the independent variables. Okay, by subtracting or dividing or by summation, you can find out the independently values of x and y. If suppose we have only single equation is given and by the single equation we could not find the values by subtraction, addition, because there is only single equation is there. Therefore, by putting the different values of x, okay, suppose I put the x is equal to 0, then 2y is equal to 20, therefore y is equal to 20 upon 2, y is equal to 10. By substituting different value of x, we can find out the different value of y. Therefore, x is our independent variable. Okay, we use the any value of x, independent variables. And for y, it is a dependent variable in which is depends upon the x, the value of you taken, and the value obtained of the y is depends upon the value of x. Therefore, by studying this, okay, we are not interested in this, we are interested in this when there is a variables to x is the one of the variable and y is the one. There are the two variables and equation is given only one. Okay, in such situation, we have a formula by obtaining from this relation number of independent variables is equal to number of variables minus number of equations. Therefore, in this case, we have equation is provided only one. Okay, therefore, minus 1 in case of we put the value number of equation provided 1 and number of variables is the x and y. There are the two variables is there and equation is 1. Therefore, 2 minus 1 therefore is equal to 1. Number of independent variables is 1. By using this equation, we can find out the number of independent. In this case, y is the x is our independent variables, and by using this equation, we can find out the independent variables. Okay, therefore, the formula, you have to remember that formula, your number of independent variables. Okay, instead of independent variables, we use the degree of freedom. Variables is equal to number of variables minus number of equation. With this formula we will use in find out the degree of freedom. Okay, mathematical form we can obtain from this. If suppose we have the one is the component, we consider at first component and then phases. If we have single component system, okay, in this system if you take, suppose water system is there, ice gives the water, that is liquid water, and gives the vapor. Okay, in total system if it is 10 gram, if it is the 10 ml, okay, therefore in ice also it is a 10 ml, in water the total system will be 10 ml. Okay, there is no need to explain other than the concentration there. Okay, already in this system temperature and pressure is independent variables. Okay, independent variables and dependent variables all we consider under the number of variables. Okay, we are not considering independent variables. In this case we have used the number of degree of freedom. Therefore in a number of variables we also consider the independent number of independent variables for a system. Therefore temperature and pressure is already independent variables. For we have considered the for the concentration. Okay, we are studying for the concentration. Okay, therefore if the single component is there, therefore no need to specify concentration, okay, in each step. Okay, because no need to specify in ice, no need to specify in water, no need to, because it is only single component is there. Therefore there is no independent, zero concentration variables is there. Okay, by using the there is only one component, therefore we cannot use the concentration. Or if our system is two component system, if there is a copper plus zinc system is there, therefore we have to specify if total volume is the 10 gram. Okay, this total volume of total its quantity is 10 gram. Therefore you have to specify any one concentration. Okay, if you consider, if you say the 4 gram copper is there, then zinc will be the 6 gram. Or if you consider, if you say the 6 gram zinc is there, you can ultimately say that you should require there is the copper is the 4 gram. Therefore any one quantity you have to specify. The ratio of the you have to concentration of zinc, the ratio you have to specify one of the quantity, one of the concentration you have to specify, then you can specify the other concentration. Therefore in this case the concentration required one substance or one composition you require, composition of one substance is required. As like if system is 3 component, okay, suppose x plus y and z system is there and total is the 10, and if suppose we get the z is the 2 gram, y is the 6 gram, therefore x will ultimately we can say the 2 gram. If suppose I said x is the 2 gram, z is the 2 gram, then you can say the y is the 6 gram. Okay, any two concentration or any two composition you can specify, then you have to use the two composition you should require there. In a 2 component system there is a one composition required. In single component reaction 0 composition is required. Therefore from this all we can say that for this is for the single phase. Okay, we consider only for the single phase. Therefore we found that in this case component is the 1, therefore C minus 1 is equal to 0. If component is 1 minus 1 is equal to 0. In this case component 2 minus 1 is equal to 1 composition required. In this case 3 component minus 1 is equal to 2 composition, so on. 4, if it is 4 minus 1, 3 composition required for the describe the 4 component system. Okay, therefore in this case we can derive one equation, that is the components minus 1, and this is for the if phase is only 1 there into 1, then if phase is 2 then into 2, if phase is 3 you have to use the 3, and if phase is p time is phase there, C minus 1 into number of phases, and plus our independent temperature and pressure is also there, independent variable plus 2. Okay, this is the number of variables you found. Number of equation we can find out from the phases. Therefore, number of equation we can find out if suppose we have the ice is equilibrium with the water and water is equilibrium with the vapor. Okay, therefore in this case we consider if we have phase is only 3 phases is there. Okay, in this case 3 phases is there, ice, water and the vapor. Now in previous lecture we said that for the condition of equilibrium, the molar partial free energy of any component or any composition or any constituent is the same for each phase. Okay, partial molar free energy should be same for each phase, then equilibrium is maintained. Okay, this is the condition for the equilibrium. Therefore in this case phases is 3 and number of equation we can given as phases. Suppose if phases are alpha, beta and gamma is there, okay? We give the name. Therefore our partial molar free energy for alpha is equal to partial molar of free energy gamma. Okay, gamma. And second, we can say that partial molar free energy of alpha is equal to partial molar free energy of the beta. Okay, therefore we have to use the only 2 equation. Okay, ultimately you can say that the gamma bar alpha g gamma bar is equal to g alpha bar, because g alpha is equal to g gamma, g alpha is equal to g beta. Therefore this is equal to this. Okay, simple mathematically we can explain that g gamma bar is equal to g gamma b. Okay, therefore if component is 3 you have to use the 2 equation. Therefore if phases is 3, therefore phases minus 1. Okay, therefore 2. In this case 3 is phases 3 minus 1, you have to require the 2 equations. If phases is 4 minus 1, 3 equation you should require. Therefore we find the one rule p minus 1 equation you require for the one component system. Okay, if component is 2 you have to write the into 2. If component is 3 into 3, if component is c times, then p minus 1 into c equation you should require for explaining this rule. Therefore by using this equation, number of, instead of independent we write number of, okay, instead of number of freedom f is equal to our rule number of variables. Okay, number of variables is we obtain c minus 1 into p plus 2, c minus 1 into p plus 2. Then number of equations p minus 1 into c plus p minus 1 into c. Okay, we multiply this c into p minus p plus 2 plus c into p minus c. Okay, therefore cp is cancelled. Therefore equation will become that is minus c. P minus 1 we have used here. Okay, instead you can check p minus 1 c. Therefore p minus 1 minus 1 c. Okay, we have used. Therefore the p cp into minus p plus 2, and in this case cp minus c. Okay, something in this case c minus 1p plus 2 we have used in this case as our number of variables. C minus 1 into p, it is correct. C minus 1 into p plus 2, c minus 1 into p plus 2, that is the correct one. and then we have to make this is the minus. Okay, this is the minus. We have used in this case plus. Remember, this is a minus. Therefore, in this case minus, and this is the plus. Okay, Cp minus and Cp minus will be cancelled. Is equal to, we obtain C minus P plus 2. Okay, hence we have obtain the C minus P plus 1, that is the Gibbs phase rule we obtain by the number of steps. This is all about the Gibbs phase rule we obtain here. Thank you very much.